It will record now. Okay. So we are starting with the new topic, preparation of colloids. And here, yesterday I told you, lyophilic colloids, it is very easy. You just mix the dispersed phase with the dispersion medium, you get lyophilic colloids. And for lyophobic colloids, special methods are required. So these are the methods. In your syllabus, there are 3 methods in your syllabus. The first one is chemical method. The second one is electrical disintegration. And the third method is peptidization. Is that clear? There are 3 methods of preparing lyophobic colloids. There are other methods also in your book, in your syllabus. 3 methods are there. The first one is chemical method, and the second one is electrical disintegration or Bredik's arc method. Electrical disintegration or Bredick arc method. Third one is peptidization. Now listen careful. From here onwards, each topic possibility of questions are there. And so we will start with the chemical method, the first method, chemical method. And any doubt you can ask, children. Okay. So chemical method, chemical reaction. So some equations will be there. So that is, I'm going to the board now. You tell me whether you can see the board. Can you see the board?
Ma'am, only top part is visible.
Now?
Yes, ma'am.
Now?
Yes, ma'am, we can see.
Okay. So chemical method means chemical reaction. And very important, double decomposition. There are 4 methods: double decomposition, oxidation, reduction, and hydrolysis. So,
Ma'am,
yes.
could you tilt a little more?
Now?
Ma'am, towards the down little.
Towards the?
I mean towards down little. Could you bend? The upper part of the board is seen.
Not clear. Now? Is it clear now?
Ma'am, it's fine now.
Fine? Okay. So, double decomposition. 4 methods are there. 1, double decomposition. 2, oxidation. 3, reduction. And 4, hydrolysis. So here you have to see equation means you have to learn little sort of by heart. And a double decomposition, you will get this colloid, arsenic sulfide. Colloid, another name of colloid is Sol, SOL. Arsenic sulfide you will get by double decomposition. Oxidation you will get sulfur Sol. And reduction you will get gold.
Ma'am? Ma'am, my connection is a bit weak. Can you tell what are these 4 processes for?
No, I didn't understand the question.
Ma'am, when you were explaining this, my connection was a little weak. So, what are these?
Chemical methods of preparing the colloids. And the 4 methods are there: double decomposition, oxidation, reduction, hydrolysis. Okay?
Yes, ma'am, yes.
And so for double decomposition, you will get arsenic sulfide Sol. Sol, SOL. Sol means colloid. And oxidation, you will get a sulfur Sol. Reduction, gold. And hydrolysis, you will get a ferric hydroxide. This you learn by heart. We will go to the equations. All of you go see the board and learn by heart. For chemical methods, double decomposition, you will get arsenic sulfide. Oxidation.
Ma'am, could you tilt the screen a bit, ma'am? Half of the board is visible.
Okay. Okay. Is it okay now?
Ma'am, tilt it a bit down,
Bit
the
more.
screen.
Bit down. The screen you can tilt a bit down, ma'am.
Right.
Yeah, now it's fine, ma'am.
So you see this and learn double decomposition, arsenic sulfide. Then we will write the equation so that you
Ma'am,
can.
arsenic sulfide is the product or?
So it is the product. You will get this sol. Sol means colloid. And
Okay.
this is sulfur sol, gold. These are the products. You should know because you will be learning by heart now the method.
So, ma'am, we have to learn the equations for these.
Equations I will teach you now. This is how I teach always now. You are going
Okay,
to
ma'am.
learn the equation now itself. So the product, if you know, for you it is easy. Clear? Have you learned?
Yes, ma'am.
So now we'll start with the equations.
Ma'am, 1 minute.
Okay. Okay, the first one. So already you learned that arsenic sulfide sol is obtained, isn't it? And so the method is arsenic oxide you will take and pass hydrogen sulfide. You will get arsenic sulfide sol and the byproduct, guess and say, water, isn't it? And the 3S here, so 3 H2S and oxygen 3, so 3 water, it is balanced, isn't it? So write and learn, this is double decomposition. Arsenic sulfide, you will pass hydrogen sulfide through arsenic oxide. All of you learn. Okay, done? And write 2-3 times and learn double decomposition. We'll go to the next, oxidation. Oxidation, we will get the sulfur sol. And so you can remember hydrogen sulfide is common here. One of the reactants is hydrogen sulfide, other one is sulfur dioxide. So hydrogen sulfide. So sulfur plus water, isn't it? So two oxygen. So 2 hydrogen sulfide, 3S. Clear? So you will learn like that oxidation, you will get the sulfur sol and one reactant is common hydrogen sulfide and that way you can remember. Other one is sulfur dioxide. Write both and learn. 2-3 times you write and learn.
Done, ma'am, both.
Done? So 2 you learned and now the third one, reduction. Reduction. Reduction, we get gold sol. So that you already know that gold. So you have to take a gold compound, that is auric chloride plus formaldehyde is the reducing agent. Auric chloride plus formaldehyde plus water. You will get gold sol plus. From this, each term we are changing the C. This will be converted to formic acid and chlorine has to come out, isn't it? HCl. You got? Here you have to learn by heart certain things. So this water you should not forget. The process is reduction. Reducing agent is formaldehyde. These are the things you see and learn. And the gold sol you will get Formaldehyde will be converted to formic acid and HCl. Now balancing is left. Here 3 and 3 water. So you will get 3 here and 2 gold and 6 HCl and 2. Got it? So write 2-3 times and learn this. And remember the things I told you. Gold salt. So gold compound is auric chloride. And formaldehyde is the reducing agent solution, water. Now gold chloride is converted to gold. Chlorine comes out as HCl, HCHO, HCOH. Now balancing. Got it? Okay, children? Okay, now the last one, hydrolysis, which is very
Yes, ma'am.
easy. The salt is ferric hydroxide. So we have to take an iron compound. Iron compound is ferric chloride and hydrolysis for water. So Cl has to come out, isn't it? HCl. So that is it. So 3 hydrogen there. So I will put it as 3 here, 2 here, and 2. So HCl will be 6. So is it balanced now? 3 oxygen? No. 3 oxygen. Suppose I don't put that. 3 oxygen, it is so 6 hydrogen, 3 plus 3. This is balanced, isn't it? Okay. Any doubt on this?
No, ma'am.
So now, board is not required now. Okay, all of you, all the 4 methods, 2 times write and learn and tell me whether you learned or not. Those who learned, you have to see once more, I will say. This is very, very important. The questions after learning, I will tell you. Okay, 3-4 methods are there. Double decomposition, as I told you, you will get arsenic sulfide. So you should take an arsenic compound, which is arsenic oxide plus H2S. Now the second one, oxidation, you will get a sulfur salt. So sulfur dioxide plus H2S. Now third is reduction, you will get gold salt. So auric chloride, HCHO plus water. Fourth is hydrolysis, you will get ferric hydroxide. So FeCl3 plus water. All of you learn now, children. And tell me those who learned fast, learn. Ajay, are you there? Ajay? Ajay, are you present? Are you able to follow Ajay? Prashant, done. Very good. Prashant, very good. Write one or 2 times more. You came first. Prashant?
Yes, ma'am.
Varsha, done. Prashant, write 2-3 more times. Good effort, Prashant.
Done, ma'am.
Good. Kirtana, Amitav, all are smart children. Do fast and then we'll go to the next. Anand, not at over. Nearly done. Do Anand fast. See, the children are doing very fast. What about Jay, Agnel? Okay, majority of the children are very smart children. Good. that is the effort you should take because of the situation. Then you should make use of whatever time you are utilizing. It should not go waste. Very good. So chemical method we have learned, and next is electrical disintegration. Here also, here I think I will draw the diagram and explain. So from the name itself, it is electrical method. Okay. And before that, the questions from chemical method. The questions, one is they may ask you directly. How do you prepare or write any two methods, chemical methods of preparation of colloids? That is one way. And most probably that way they may not. How do you prepare sulfur sol? How do you prepare gold sol? Like that. So this electrical disintegration, gold also you can make either by electrical disintegration or chemical method. But arsenic sulfide, ferric hydroxide, sulfur sol, all these are by chemical method. Clear? This type of questions they may ask you. Okay? Or they can take any one method and ask you also. Clear? Now, electrical disintegration. So this is an electrical method. I will come to the board. Can you see the board? Can you see the board? Board is visible?
Ma'am, the lower part is not visible.
Now?
Yes, ma'am.
Okay. So the method. These are used, this method is used to make salts of metals such as gold, silver, platinum. Okay. Suppose I want to make gold sol, gold, colloidal solution of gold. I will take 2 gold electrodes. And that is dipped in dispersion medium. Okay. So this is dispersion medium. And the whole thing is placed in a freezing mixture. This is the freezing mixture. And an electric arc is struck between the 2 electrodes. We have to apply an electric field. So what happens? The electric field, when you apply very high heat, it vaporizes some of the metals. And so the
Ma'am, can you
metal
start again
will,
on this, ma'am? Can you start this again? This
is for making the colloidal solution of metals such as gold, silver, and platinum. So whatever metal sol you want to make, you will take electrodes of that metal. Suppose I want gold sol, I will take gold electrodes. Clear? And an electric arc is struck between the, you will apply an electric field. And the electrode is dipped in a vessel containing dispersion medium. And that vessel is placed in a freezing mixture. And so when you apply an electric arc or apply an electric field, some of the metal will vaporize. And so the vapor will condense, and vapor will go to the dispersion medium, condense, because we are keeping it in a freezing mixture. Condense and you get the sol. Clear?
yes, ma'am.
Is it clear?
Yes, ma'am.
Ma'am, can you explain once more?
See, it is very simple. You take,
Yes, ma'am.
suppose you want the gold sol, you will take 2 electrodes of gold and you are going to pass an electric field. So the sentence they said, if the electrodes are, the 2 electrodes, you apply an electric field and that electrodes are placed in the dispersion medium, and the vessel containing the dispersion medium and the electrode is placed in a freezing mixture, and you struck an electric arc between the 2 electrodes. So Electric field when you apply means high heat, isn't it? That vaporizes some of the metal. So the metal will convert into the vaporized metal. Some of the metals that is immersed in dispersion medium, and you have to vapor should cool down, isn't it? That is why we kept in the freezing mixture. So here condensation also take place, isn't it? It is like breaking. First it is converted into the vapor state, that is condensed in the dispersion medium, and you will get a colloid. Clear?
Yes, ma'am.
Okay.
Ma'am, but the metal vapors will also evaporate, like they'll escape out from the thing. Right?
What Anand?
The metal vapors will escape from the system,
Not
right?
escape out. It is immersed. Metal is immersed in dispersion medium. It will go to the dispersion medium, and since it is very cold, because we already placed in the freezing mixture, it will get dispersed in the dispersion medium, and you get a colloidal solid.
Okay, ma'am.
Okay. So this Briggs arc method, the question, can you see me? Can you see me?
Yes, ma'am.
Yes, ma'am.
So the question, direct question, and suppose indirect question, how do you make a sol of platinum or a silver sol or a gold sol? Okay, so this is the method. So mostly they ask like this, which method is used to make silver sol or platinum sol? So these are metals. So we apply an electric field, vaporize, and that will disperse in the dispersion medium. Okay, clear? So this involves dispersion as well as condensation. We'll go to the next method. Each point, each topic is very important.
Ma'am, you will make us underline. What should we write, like if the question comes?
It is very well explained. Chemical method, the reaction you have to write. Here, you have to learn, it is that only. Electrical, this involves dispersion as well as condensation. It is what is given is well explained. Colloidal salts of metals such as gold, silver, platinum can be prepared by this method. In this method, an electric arc is struck between the electrodes of the metal immersed in the dispersion medium. The intense heat produced vaporizes the metal, which then condenses to form particles of colloidal size. Very good, well explained. Full you have to learn. Okay?
Okay, ma'am. And the diagram? That also?
Required.
Okay.
Diagram is required. Okay? Now, next one, peptidization. So in this method, you are converting a precipitate into a colloid. Listen to me carefully. These are the important points. You are converting a precipitate into a colloid by shaking it with the precipitate. You shake with a dispersion medium containing small amount of an electrolyte. Got the point? So peptidization, the question will be explained the following. Peptidization. It is a process of a method of converting.
Ma'am, I didn't understand that shaking it with a dispersion medium point.
Dispersion medium is required, na? What is the topic?
Shaking it. Shaking it.
But we are adding an electrolyte also.
Okay.
You are saying it is not, it is lyophobic. That is why you are saying.
No, ma'am, I just didn't understand what that meant.
The process is making a colloid, isn't it? So the method is converting a precipitate. Precipitate is not a colloid. Converting a precipitate into a colloid. And a colloid, to make the colloid, you need a dispersion medium, no? By shaking it with a dispersion medium containing small amount of electrolyte. And the small amount of electrolyte you add is the peptizing agent. Okay?
Yes, got it.
So this I will tell what to here you can. Peptidization definition only will be asked. A process of converting a precipitate into colloidal sol by shaking it with the dispersion medium in presence of a small amount of electrolyte. The electrolyte used is the peptizing agent. Clear? Now the next paragraph they are saying what
Ma'am,
happens. Yes.
ma'am,
Yes, there
ma'am, can
is.
you repeat that? Ma'am, can you repeat that lyophobic point? You were saying something.
No. What I was saying, Amita was asking why you are shaking with a dispersion medium. Because I said, lyophilic colloids means you just shake with the dispersion medium. And the beginning I said, these are special methods used for making lyophobic colloids.
Okay.
That
So
is all.
peptization is just a lyophilic method
No, lyophilic means you don't require a peptizing agent and all. You just mix, you will get a lyophilic.
by normal shaking, right?
Ma'am, what is
Okay,
the
ma'am.
purpose of the electrolyte?
Electrolyte, otherwise it is the peptizing agent. Otherwise, you don't get the colloid. So that part only is your answer is the next sentence. I was saying the next paragraph, Anand. During peptization, the precipitate adsorbs one of the ions of the electrolyte on its surface. Got it? So this causes a development of a charge. See, you got the answer. I will come to the board for the stability of colloids. Even though it is coming in the next topic, I will explain since Anand asked the doubt. Okay, so I'm taking a colloidal solution. Okay. And you know that these are dispersed. They are dispersed. That is it, colloids. Isn't it? That is why it is a colloid. If they settle under gravity, it is not a colloid. They are scattered, dispersed. And the colloidal particles are having, each colloidal solution, the colloidal particles are having a charge, either plus or minus. So, all the particles will have the same charge. So what happens, I am going to explain the stability of colloids. What happens, similar charges repel each other and they don't aggregate and settle under gravity. That explains the stability of the colloid. Got it? Understood?
Ma'am, can you
Yes,
repeat it
ma'am.
once more, please?
This
Once more, ma'am.
I am explaining why the colloids are stable. So suppose these particles plus and minus, they will come closer, and they settle down. Once they settle down, this is not a colloid. For a colloid, the particles should be dispersed, right? And if the particles are dispersed properly, the colloid is stable. So why the colloid is stable, or I am explaining the stability of colloid. The reason is, why the colloids are stable, the reason is the colloidal particles are charged, either positive or negative. If in the case of a positive colloid, all the colloidal particles are positively charged. The colloidal particles means the dispersed phase. They are positively charged. If they are, suppose in this case, they are positively charged, then the positive charges will repel, isn't it? They don't come closer. And so they will be dispersed. If the opposite charge means they come closer. When they come closer, they will come down, settle under gravity, and that colloid will be unstable.
Ma'am,
So
so
the
basically
stability
all
of colloid, the reason, this explains the stability of colloid. It is because of they are charged particles, and the same this year board question they asked this question. Okay? Is it okay? Clear?
Yes.
Ma'am, are they always
Yes, ma'am.
positively charged, ma'am?
No. It can be negative also. There are negative soles also. If they
Ma'am, just that all the particles will have the same charge. It can be
same
positive or negative.
is positive, then all the particles are having positive. If it is negative, all the particles are having negative charge. Okay?
Yes, ma'am.
Okay. Ah. So now Anand's question is answered. Why you add an electrolyte? So
Yes, ma'am.
the electrolyte. So the colloidal particles absorb from the electrolyte, and that explains the stability. Okay. So that is about the methods of preparation. So there are 3 methods of preparation: chemical methods. In that 4 methods we learned, and electrical disintegration or Bredik's arc method. That is an electrical method. Then peptidization. So the
Ma'am, peptidization only the definition.
preparation and the electrolyte added is the peptizing agent. And then the next small paragraph, the first sentence I read. During peptidization, the precipitate absorbs one of the ions of the electrolyte on its surface. This causes development of a charge. And okay, so that is it.
That's
Ma'am,
all, ma'am.
Anand.
one more doubt.
Ah,
Why is it called peptidization when it does not involve any peptides?
any?
Peptides or any
That peptide is different. That peptide you are saying the protein polypeptide. That
Yes,
is
ma'am.
different. You can give any name. That is different. This is peptidization. That is polypeptide. Okay.
Okay, ma'am.
So any doubt in this? Even though it looks very, very simple, but each topic questions. And this year's question, I will tell you. There is, see, this year onwards, a passage will be given. I told you in the class. And they ask 5 questions. And the answer will not be there in the passage. That is the funniest part. And this time they gave the passage about colloids. And one of the questions was this. Explain what explains the stability of the colloids. What is the answer? Why the colloids are stable? That was the question. What answer you will say?
The particles
because
contain the same charge.
The colloidal particles are having either positive or negative charge. So you have to say that the key they said the similar charges repel. That is repel word. And then so they do not settle under gravity. Got it?
yes, ma'am.
So that was one question. And 5 marks in that very first question was from colloids surface. So then as I teach you, I will tell the other questions. Okay. So methods, only one topic so far we learned, methods of colloids. I am going slow because it is very, very important. Even though it is very simple, and the children, they say equations are better, ma'am. We are finding it difficult to learn this chapter. Why? The very first day I taught, that time they did not learn. And this every year I am hearing. That is why I said, learn and come. And tomorrow, the girls are learning, boys are not at all learning. Learn and come. Right? Are you hearing?
For
Yes, ma'am.
numericals, will they give logbook in the board exam, ma'am?
Only the log paper, not the full book. The paper they will give you. Okay?
Okay, ma'am.
Any other doubt? We'll go to the next topic. Each topic is very, very, very important. Each topic is a question. Next topic is purification of colloids. So many years back, once what is the requirement of purifying the colloid? So then common sense, the colloids contain impurity. And the actual answer is, you see that when you prepare a colloid by chemical method, or even in this peptidization or any method, there will be excess of electrolytes present. And of course, impurity. Impurity is one point. Impurity, soluble impurities, you have to say the answer. The book, they said 2 reasons: excess of electrolyte and soluble impurities. And a small amount of electrolyte is required for the stability of the colloids. If you remove complete the amount of electrolyte, then it will coagulate or it will settle under gravity. It will become unstable. A small amount of electrolyte is required, but excess means impurity, isn't it? So that is the requirement. See how the questions are coming. Why the colloids need to be purified? Because the colloids we prepare are having 2 points: excess of impurities, excess of electrolytes and soluble impurities. So, and then you remember that a small amount of electrolyte is required for the stability of the colloids, and excess of electrolytes and the impurities need to be removed. That is why we purify colloids. Clear?
Ma'am, can you repeat the last point again?
See, well, the question is like this. Why do we need to purify colloids? So, 2 points only. The colloidal solutions we prepare contain excess of electrolyte and soluble impurities. So, they need to be removed. And the last point I said, a small amount of electrolyte, we should not remove the complete electrolyte. A small amount of electrolyte is required for the stability of the colloids. That only 2 points only I said. Okay?
Okay, ma'am.
So, now Agnel and Prashant sons, you are calling me mama? Okay. Okay, that is okay. So, next point, purification methods. We are coming to the purification methods. The purification methods, the first method is dialysis. Okay, now here the question is a direct question, the definition. So when the definition is asked, you have to write the correct sentence with the correct term. Okay, so dialysis, I will explain what is dialysis. We use a membrane, a permeable membrane. What do you mean by permeable membrane? Which allow some of the ions to pass through the membrane. Okay, so what we do, first what we do.
Semi-permeable or permeable, ma'am?
Both are the same.
Okay.
So here the impurities will diffuse through the membrane. Okay, that is the principle, dialysis. Or if I say how do we conduct, you will understand better. You will take, first you will make a bag made up of a permeable membrane. You take a bag made up of a permeable membrane. And I think I should go to the board. I will. Okay, so here is the bag made up of permeable membrane. You have to draw proper diagram if at all asked. Okay, inside you will take colloidal solution. And the full bag is placed in water. And you can say continuously you have to pass and fresh water. So inlet and outlet. You understood? Why inlet and outlet? Because fresh water should be passed continuously. Okay, so the bag is containing the impure colloidal particle that is placed in water. So what happens? The impurities will diffuse through the membrane into water. And why we are continuously supplying fresh water? Because the process will speed up. If you completely, first the ions come, that is removed. When fresh water is there, the process is fast, it becomes faster. Okay, got it? Any doubt?
This whole bag is made up of this thing, membrane.
Membrane.
Okay.
Okay, in the textbook it is like the shape of a bottle, isn't it? Anyway, any shape you can take. Understood the concept?
Yes, ma'am.
Yes, ma'am.
Okay, my sons, Agnel and Prashant, you understood?
Oh, what is that crystalloid given in the diagram there?
What is it?
Crystalloid.
Colloid. What is that? Crystalloid. That is the impure water plus crystalloid. It is the impure colloidal solution.
The excess electrolyte. No?
Impure one. That is it. Inside it is the impure one.
Okay.
So the
Okay.
crystalloids are the impurities, ma'am.
No. You forget about that word. We are taking the impure colloidal solution inside the bag.
Okay, ma'am.
Okay. So
Yes, ma'am.
dialysis, and then the question, most probably whenever the question comes, it is the definition. So you have to use the word diffusion. Remember, otherwise no mark. So I am going to read the definition. It is a process of removing a dissolved substance from a colloidal solution by means of diffusion through a suitable membrane. All of you understood? And as such, you have to learn that definition. Okay? So it is a process of removing soluble substance from a colloid by diffusion through a suitable membrane. Any doubt in that? And the process is, I told you, you have to take the impure colloidal solution in a bag made up of a membrane, suitable membrane, and place that bag in a vessel containing water, and continuously you pass fresh water. The reason is the process will speed up if fresh water is there. More ions will go into the water. Clear? Yes or no?
Yes, ma'am.
Yes, ma'am.
Prashant has some doubt. How does impure particles move? Through diffusion. Through the membrane. Membranes will have pores, isn't it? And the colloidal particles, the impurity ions, based on the size, the impurities are smaller in size. Colloidal particles are bigger in size. And so the pores are small. So this will allow, that is why permeable membrane, it will allow only some ions to pass through. So that is why we are using the word diffusion. Okay? Okay. So that is the dialysis. Clear? Any doubt?
No, ma'am.
Okay. So now electrodialysis. I will again go to the electrodialysis is a slow process. To speed up the process, if we apply an electric field, so from the word itself, electric, by applying an electric field, we can speed up the process of dialysis, that is electrodialysis. Okay, so I will again go to the board. It is easy for you to understand. And this will happen only if the colloidal solution is an electrolyte, if it contains the impurities are electrolytes. Because when you apply an electric field, the ions will move, isn't it? So I will go to the board again. Same arrangement. The difference is you will place two electrodes. One is positive, other is negative. So two electrodes are fitted, and so then what happens when you apply an electric field, the negative ions will move towards the positive electrodes, and the positive ions will move towards the negative electrode. So the process is fast now. Clear?
Yes, ma'am.
Can you repeat, ma'am? My video paused.
It is like I showed. The arrangement is the same. The difference is you will be fitting two electrodes, a positive and a negative. So when you apply an electric field, now the electric field is applied, isn't it? Ions will move faster. Positive will move towards the negative electrode, and the negative will move towards the positive electrode. Clear?
Ma'am, we are just speeding up that process using this thing.
Yes.
Okay, ma'am, got it.
Okay, arrangement is the same. Extra thing,
Yes, ma'am.
two electrodes we fitted. Okay, so here also most probably the definition, And so electrodialysis, you will say the process of dialysis is quite slow. It can be made faster by applying an electric field if the dissolved substance in the impure is only an electrolyte. This will happen if the impurity is an electrolyte. This process is electrodialysis. The colloidal solution is placed in a bag of suitable membrane while pure water is taken outside. Arrangement is the same. Electrodes are fitted in the compartment. The ions present in the colloidal solution migrate to the oppositely charged electrodes. Clear? Very well explained in the book. So this is the second method of purification. The first method is dialysis. Second method is electrodialysis. Clear, children?
Yes, ma'am.
Now,
Yes, ma'am.
it is very easy, but take time, take the pain of learning. Once it is learned, you will not forget also. Okay. Now the third method is
Ma'am,
yes.
Ma'am,
Ah.
both the processes are used for removing excess electrolyte. Ma'am.
Yes, yes. Idris, what is the
ma'am,
doubt?
ma'am, you said that negative ions and positive ions will move towards respective anode and cathode. But but earlier you said that colloidal solution have only the same charge, right?
No, this is the impurity. Electrolytes only we are removing, not the colloid. Colloid will stay in the bag.
Colloid.
Colloid will stay in the bag. We want to remove impurities. The electrolytes only we want to remove.
Electrolyte.
Yes, yes.
But
This is for removing. Impurity is the electrolyte. Isn't it?
Okay, ma'am.
Got it?
Yes, ma'am.
Colloid will not move. It will be in the bag. So pure colloid will be inside the bag. Okay? Okay, we'll move towards the next third one. Anybody? Any doubt?
No, ma'am.
No, ma'am.
The third one is ultrafiltration. Okay, now listen to me carefully. This is from the word itself. You will remove the impurity through a filter paper. Okay, so you must have done in the lab to filtering in using a filter paper. If you use ordinary filter paper, the pores are big. The colloids also will go through the pores, isn't it? So what we do, we will reduce the pore size of the filter paper by applying collodion in it. So when you apply collodion, and so collodion, what is collodion? It is nitrocellulose. This question was asked once. Collodion is nitrocellulose and in a mixture of alcohol and ether. Okay, that is collodion. So we take nitrocellulose in alcohol and ether and apply in ordinary filter paper and harden it by adding formaldehyde and dry it. So you will get this special type of filter paper called ultra filter. Understood? And when you
Ma'am, can you please repeat it once?
see, this is filtration. So ordinary filter paper, if you use, the pore size is more. Large pores are there. The colloids also will come out. We want only the impurities to filter out, isn't it? So what we do, we reduce the pore structure by applying collodion. Okay, so ordinary filter paper you take and you apply collodion on it, and then you have to harden it.
Ma'am, what is collodion? It is the mixture of something you don't know.
I will come to that. So ordinary filter paper you take, apply collodion and then harden it by formaldehyde and dry it. You will get this special type of filter paper called ultra filter. And that filter paper, if you use and filter, the colloidal particles will not go through the pores because we reduce the pore size. And only the impurities will go and you get a pure colloid. Now, what is collodion? It is a solution of nitrocellulose in alcohol and ether. Is it clear?
Yes, ma'am.
Okay, so again I will say ultrafiltration, it is filtration only using an ultrafilter. So why we are using an ultrafilter? Ordinary filter paper is having the pore size more. Large pores are there in the ordinary filter paper. So we reduce the pore size by applying collodion. And what is collodion? Nitrocellulose, a solution of nitrocellulose in alcohol and ether. And you apply collodion, harden it by formaldehyde and dry. You will get this special type of filter paper called ultrafilter. Now, then the process is you filter using ultrafilter. Anand is having some doubt.
Yes, ma'am. Like, why should we harden the filter?
Then that is the method. Na? So you need to be, otherwise when you apply a nitrocellulose in alcohol and ether, it will be very soft. You cannot filter. So harden it. That is made by hardening it with this formaldehyde and dry. Okay. And so that is ultrafilter. Use it, and use means filter using ultrafilter. The impurities will go and you will get the colloid, pure colloid in the filter. Okay. And so this process is also very slow. So to speed up the process, you can apply, if you apply pressure, then the process will be speeded up. Now the definition can be asked. Definition, I come to the book. Ultrafiltration is the process of separating the colloidal particles from the solvent and soluble solute present in the colloidal solution by specially prepared filters which are permeable to all substances except the colloidal particles. You understood the definition?
Yes, ma'am.
If it is very, very difficult, you can say that ultrafiltration is the process of separating the colloidal particles from the impurities using a special filter called ultrafilter. If it is very difficult, that sentence. Got it?
Yes, ma'am.
Okay. So then I said in a one more question, what is collodion? Collodion is made up of what? That question came once. So you have to, the collodion is 4% solution of nitrocellulose in a mixture of alcohol and ether. Underline. And ultrafilter is made, paper is made by soaking the filter paper in colloidal solution, hardening by formaldehyde and drying it. The last point you will say is to speed up the process, pressure is applied. Okay, so then, so once you get in the filter paper, you will get the colloidal particles, but the dispersion medium is removed, isn't it? So you add fresh dispersion medium, you will get to the pure colloid. Got it? That is the last point they are saying. You see the sentence, the colloidal particles left on the ultrafilter paper are stirred with fresh dispersion medium to get pure colloidal solution. Understood?
Yes, ma'am.
So, purification methods are done. Clear?
Yes, ma'am.
So today's each topic is very, very important. So we started with, we are going very slow because of the importance. It is very important. So we started with the methods of preparation, chemical method, electrical disintegration, peptidization. Then we learned 3 purification methods, dialysis, electrodialysis, and ultrafiltration. Clear?
Yes, ma'am.
Yes, ma'am.
Next topic is little more.
Ma'am, in ultrafiltration, the last three lines I didn't understand.
Varshini,
Yes, ma'am.
Last 3 lines. Okay. Ultrafiltration is a slow process.
Yes.
That to increase to speed up the process, you can apply pressure or suction. If it is applied, process will be speed up. Now the
Yes,
last
ma'am.
point they are saying is, see, in the filter paper you will get the colloid as a slime only, because the medium, the water part is gone now. So you will get
Yes.
that. You have to use fresh dispersion medium to get the pure colloidal solution.
Okay, the thing which is left on the filter paper is nothing but the colloid itself.
Only the particles you will get as a slime only, not the colloid. Dispersion medium already went out. So you have to add a fresh dispersion medium.
Okay, ma'am.
Okay. So now the next part is slightly difficult, the properties of colloids, and very, very important. Next part. So I will go slow. If you do not understand, you can ask. Okay. And don't hesitate to ask if you do not understand. So the properties of colloids. So there are different properties of colloids. The first one is colligative property. The second one is an optical property. And the third one is a mechanical property, that is Brownian movement. Optical property is Tyndall effect. And then the fourth one is, in fact, the third given in the book is color. And the fourth one is Brownian movement, that is the mechanical property. And the fifth one is electrical property. So these many properties are there. One by one we will see. Okay, you have to learn the properties. Okay. Now the first property is colligative property. Now you know that here only one point. You know that the size of colloidal particles are large than the true solution, particles of true solution, isn't it? So when you talk about the colligative property, you learned in solution 4 colligative properties. When you talk about the colligative properties depend on the number of the particles, not on the nature. Since colloidal particles are big compared to the particles of true solution, the number will be reduced, number will be less. So the colligative properties values will be less than that of the true solution. Got the point?
Ma'am, can you repeat, ma'am?
Colligative properties are properties which depend on the number of particles. So here our colloidal solution, since the size of the particle is more, the number will be less if you compare with the solution, true solution. Isn't it? So the number of particle will be less, so the colligative property will be less. Got it?
Yes, ma'am. Yes, ma'am.
The values of colligative property will be less. Why? The size of the colloidal particle is more. So since the size is more, the number will be less. And since the number is less, colligative property will be less compared to that of the true solution.
Okay, ma'am.
Done. Now this next point is optical property. This is very important, Tyndall effect. Optical property. Here one is, they will ask you the definition of Tyndall effect. So first I will explain. Other questions are also possible. And Tyndall effect, it is an optical property, light, isn't it? So what happens to understand the properties? You take a beaker containing a true solution and another beaker containing a colloidal solution. Got this much? I am taking one beaker containing a true solution and another beaker containing a colloidal solution. And the first I will pass any light, even it can be a torch light. You place the two solution in a dark room and then you pass a light through the true solution. Can you see the path of the light? No. If you look perpendicular to the direction of the light, In the case of a true solution, you cannot, it will be dark only, isn't it? Because the room is dark. But if you do the same thing to a colloidal solution, you pass a light and you look perpendicular to the direction of the light, you can clearly see the path of the light. It is as an illuminating path. Who is shouting? That is called a Tyndall effect. Got it? Understood?
Yes.
So, to understand the Tyndall effect, so if you place a colloidal solution in a dark room and you pass a light, source of light through it, and you view the colloidal solution perpendicular to the direction of the light, you can see the illuminated path of the light. That is called the Tyndall effect. And this is because the colloidal particles scatter the light. So, Tyndall effect is scattering of light by colloidal particle is called Tyndall effect. Clear?
Yes, ma'am.
So, the definition is scattering of light by colloidal particle is called Tyndall effect. Okay? So, I think they have told about the Tyndall cone. I will show in the board. You can see the light as a cone in the shape of a cone. You can see this is the Tyndall cone. Okay, in the book they put it outside. It will be seen inside only, and you have to view in a direction perpendicular to the direction of the light. Clear?
Yes, ma'am.
So, ma'am, the light spreads after hitting the beaker. The light spreads and forms a cone kind of shape when we are seeing from the right angle.
Who is spreading the particles? The colloidal particles, they scatter light.
Okay, ma'am.
The colloidal particles scatter light. So the definition you have to say, if you say all this story, you look perpendicular, the path of the light is seen, no, you don't get mark for that. The mark you get is by this sentence, the scattering of light by colloidal particle is called Tyndall effect. Okay?
Yes,
Scattering of light by colloidal particles. Here another question they ask is, how do you distinguish between a true solution and a colloidal solution? You can write down the question. How do you distinguish between a true solution and a colloidal solution? So, how do you distinguish or write an experiment? It is the Tyndall effect. Okay, how will you write? You keep both the true solution and the colloidal solution in a dark room, and you pass light through both of the solution and view perpendicular to the direction of the light. The path of the light is seen in the case of colloidal solution. Illuminated path of the light is seen. That is how you distinguish between a true solution and a colloidal solution. Clear?
Yes, ma'am.
Ma'am,
Ah,
the reason is because a colloidal solution they scatter the light and true solution they don't.
they don't scatter. Only the colloidal particles. And a true solution, actually, if you speak, they also scatter. But the size of the particle is too small. So you will not be able to see it. colloidal solution, the size is comparatively big, so it is visible. Okay.
Ma'am, what is opalescence? Opalescence.
Opalescence means it is not very clear because you are seeing the illuminated part. It is not a translucent. It is not very clear because path itself is illuminated, isn't it?
Okay, ma'am.
Okay. And so like Priyanka asked a good question, true solution, the particles do not scatter or what? And so I told they also scatter, but it is not visible since the particle size is very small. And then you can ask, what about suspension? Suspension, if you take, you will not see. Why? Can you say?
Suspension particles settle down.
Jay, very good. This boy is intelligent. So, and study Jay and get a mark. Very good. So, suspension, anyway, the particles are settling down under gravity. So, that is not visible. Okay. So, that is about a Tyndall effect. And here they said, one is the definition, all of you underline. See, the Tyndall effect is due to the fact that colloidal particles scatter light in all directions in space. The scattering of light illuminates the path of the beam in the colloidal dispersion. Okay, so if you want, you can write scattering of light by colloidal particle is called Tyndall effect. And the two conditions they said, you underline that for the diameter of the dispersed particle is not much smaller than the wavelength of light used. That is the first condition. The diameter of the dispersed particle is not diameter of the dispersed particle is not much smaller than the wavelength of light used. And the second is the refractive indices of the dispersed phase and the dispersion medium differ greatly in magnitude. So two conditions are there. In the next paragraph, they said this person, Sigmondi, this person used Tyndall effect to set up an apparatus called ultramicroscope. So that is the point they are saying. What this person, he made an ultra microscope, that is the device ultra microscope using Tyndall effect. How he did, he took a colloidal solution, and when he viewed through an ultra microscope, see, for colloidal solution in the diagram and microscope is there. Without microscope also you can see Tyndall effect. And so when this person viewed through an ultra microscope, he saw the colloidal particle. He saw the colloidal particles as stars, bright stars. And that is it is like the colloidal particles scatter light, and he was seeing the light only as bright stars. Okay, so that is just mentioned there in the next paragraph. So he devised, but then the last sentence they are saying, the ultra microscope does not render the actual colloidal particles visible, but only observe the light scattered by them. So it does not provide any information about the size and shape of the colloidal particles. Okay, so mostly the Tyndall effect, they ask the definition and maybe the two conditions. What are the two conditions? The size of the dispersed particles should not be much smaller than the wavelength of light used, and both the dispersed phase and dispersion medium should have the refractive indices differ, isn't it? Should have different refractive indices. That is it. Tyndall effect. Clear? Any doubt?
No, ma'am.
Okay, we will go to color. Here in this very small topic, but so many questions were asked from color, different years. Okay, so here I will tell you, you have to sit and learn certain points. The color of colloidal solution, so first of all, you will agree with me, depends on the wavelength of light scattered by the colloidal particles, that you know. And also the size and nature of the colloidal particles, that these points are new to you. The color depends on the size of the colloidal particles. So example, here this was the question. They have given colloidal gold. Colloidal gold, if the size of the particle is very fine, it is red in color. And if you increase the size of the particle, it changes to purple, to blue, and finally to gold. You understood?
Ma'am, can you
So
repeat?
See, the color depends on the size of the colloidal particles. So one question they asked, why colloidal gold is, fine colloidal gold is red in color? That was the question asked. Okay, so it is, you may be thinking gold is gold in color. Why ma'am is saying about red? I am talking about the colloidal gold. Gold sol, S-O-L. So what answer you will say? The color of the colloidal solution depends on the size and the nature of the particles. That is the answer. The question asked was why the finest gold particles colloid is red in color. Understood? So you will say that the color depends on the size of the colloidal particles.
Light of higher wavelength. They transmit light of higher wavelength.
Ah, yes. Okay. So color depends on the size of the colloidal particles. So colloids also, there is a range, isn't it? 1 nanometer to 1000 nanometer. So in that range they are colloid. So if the particles are very fine, gold sol, red in color, if you increase the size of the particle, it changes from purple to blue and then to gold. Got that question? Point? And the next question. Yes, Vishnupriya. Any doubt?
I was telling. No, ma'am.
Okay. The next question, the color depends on the way the observer is viewing. So that question also they asked. They have given the colloidal solution of milk and water. So they said that if you view the colloidal solution, mixture of milk and water, by the reflected light it is blue in color, by the transmitted light it is red in color. Got it? So the answer, if they ask you, you will say that the color of the colloidal solution changes with the manner in which the observer receives the light. That is the point. So these are the questions they ask.
The highlighter fluid which is there, right?
The
highlighter fluid. That is also a colloidal solution, no?
Which one? Which fluid?
Highlighter fluid. Like highlighter.
Highlighter is a colloid.
No, like the fluid, which is it colloid, I'm asking?
I don't know. I don't think.
Like
highlighter, I have to see.
The UV light rays, when we direct them at it, it glows, ma'am. What? Like it's fluorescent. Like, what is the reason for that? I just wanted to ask.
Fluorescent is not a colloidal property, no? That is a different property. Fluorescence. Okay, so here only that a Tyndall effect you will see in movie hall and all, because dust particles will be there. Dust particles in air is also a colloid. There you will see that color, isn't it? Okay, so in the color I will read out. So these are the two questions, and so 3 points they said in color. The color depends on the wavelength of light scattered, that everybody knows. And two new things you learned. One is that it depends on the nature, or not the nature, the manner in which the observer receives the light. So that is the example of milk and water. If you view the reflected light, it appears blue, and the transmitted light, it appears red. So that is one question. And the next one is gold. So I will tell you. So if they ask you the milk question, You will answer the color of colloidal solution changes with the manner in which the observer receives the light. Understood? And then you say mixture of milk and water appears blue when viewed by reflected light and red when viewed by transmitted light. The next question is the finest gold soul is red in color. And for that you have to say the second sentence. The wavelength of light depends on the size and nature of particles. And as the size of the particle increases, it appears gold soul. Finest is red in color. As the size increases, it appears purple, then blue, and finally golden. Clear, children? Any doubt you can ask?
No, ma'am. Clear.
So we will see from the beginning. On the Brownian movement also I will take, and that is, but very slowly I am taking, and that is for you to learn and come. Okay, after Brownian movement we will say once more and wind up. Okay, next one is a kinetic property or mechanical property, Brownian movement. That is when you have to view the colloidal particles through an ultra microscope. Then you can see that the colloidal particles are moving in a zigzag manner. There is no proper manner. Chaotic, random, ceaseless movement of the colloidal particles you can see. That is called the Brownian movement. So Brownian movement, you see the diagram. There is no proper path. They will be moving chaotically and a zigzag way. And that movement is called the Brownian movement. So underline, when colloidal solutions are viewed under a powerful ultra microscope, the colloidal particles appear to be in a state of continuous zigzag motion all over the field of view. This motion is called the Brownian movement. Underline that sentence you have to say. When you view the colloidal solution through a powerful ultra microscope, you can see the zigzag motion of the colloidal particles all over the field. Clear? And when Brownian movement is asked, the reason is in the next paragraph. It is due to the bombardment of the particles with the particles of the dispersion media. With that, the answer is complete. Okay, so that I will, one more question is there. This is the next paragraph. The Brownian movement has been explained due to the unbalanced bombardment of the particles by the molecules of the dispersion medium. Underline that. Okay, and there is one more question. How Brownian movement explains the stability of the colloidal particles? So Brownian movement means they will be moving all over the colloidal solution, and so it is having an effect of stirring, isn't it? They will be moving, and so since they are moving, I told you already that the particles are having the same charge. They will be dispersed, means repulsion. They will not come and settle under gravity. So this question, that is the last sentence. The Brownian movement has a stirring effect. Underline that. These three sentences are important. The Brownian movement has a stirring effect which does not permit the particles to settle and is responsible for the stability of salts. Okay? So these are the questions. So,
ma'am, what is the question for the last point?
How is Brownian movement explaining the stability of the colloids? How is it contributing to the stability of the colloid? Okay, so you have to that sentence exactly. Brownian movement has a stirring effect, first point, which does not permit the particles to settle and thus responsible for the stability of the colloids. Okay, so this three sentences, tomorrow it should not be boys also smartly learn and come like girls. And girls also don't think that yesterday we learned, today we will not learn. I will be asking, and I said that there are limitations. In the classroom, how I ask, that effect will not be there, but you should understand that everything is for your good. Okay, so we will see today very, very important topics we learned. The first point was preparation of colloids, chemical methods, four methods, oxidation, double decomposition, oxidation, reduction, and hydrolysis. Then we learned about electrical disintegration or Bredick's arc method. Name also learned. Sometimes they ask what is Bredick's arc method. And then we learned about peptidization. So 3 methods of preparation of colloids. After that we learned purification. In purification we learned dialysis, electrodialysis, and ultrafiltration, isn't it? So 3 purification methods we learned. After that we learned this.
You said a easier definition for ultrafiltration.
I can't hear.
Ma'am, for ultrafiltration, you gave an easier definition, ma'am.
Ultrafiltration. The process of removing ultrafiltration, you're right. The process of separating colloidal particles, from the impurities by filtering through an ultrafilter. Okay. Then you can say an ultrafilter is prepared by applying collodion on ordinary filter paper, harden it by formaldehyde and drying it. Okay. So if they ask, you can say this. And then after filtration, the colloidal particles are dispersion medium is added to the colloidal particles to get pure colloids. Okay, Priyanka?
Okay, thank you, ma'am.
Okay, so that is ultrafiltration. So we learned the 3 purification methods. After that, we learned some of the properties. The first property we learned is colligative property. Then we learned Tyndall effect. After that, color. Then Brownian movement. So this much we learned, and please learn and come right from the beginning, those who have not learned. So we will end up today's class, but be thorough with the topics we learned, otherwise this is of no use. And tomorrow when I ask smartly, you should answer, okay? And so that is it. Any doubt or any questions you can ask.
Okay, ma'am.
Clear, ma'am. Thank you.
Okay.
It's clear, ma'am. Thank you, ma'am.